Hello, my name is Xander and welcome back to another tutorial. In this tutorial, we explore the Django secret key, and we do that predominantly through discussing cryptographically signed values. So this tutorial has multiple sections, and you can use the timeline in the video description to go ahead and move across to the section that you're interested in. So to help you decide whether you want to follow this tutorial, let me just explain what this tutorial will cover. So first up, we'll go ahead and explore in general terms what the secret key is used for, and then we'll move across to a scenario where we discuss cryptographically signed values. We'll go through a scenario, and then we're going to cover some code which will help establish the ideas that are presented in the small presentation that's provided. We'll then move ahead to the third section where we go ahead and generate new secret keys. So there's a few different techniques we can use to generate new keys. And then finally, just the basics of taking measures to secure the secret key. So hopefully at that point, you'll have a much better view or understanding of the secret key, how to generate new keys, and then how to secure them. Every time we create a new project in Django, utilizing the start project command, that will generate a new project as well as a setting file. Inside the settings file, we have the secret key. We are told in the Django documentation that if we were to remove the secret key, then Django simply wouldn't start. So let's go ahead and remove and then just start a new server. And let's just go ahead and refresh. And you can see that we're receiving the message, a server error occurred. Please contact the administrator. So clearly, the secret key is the mandatory setting that's required. So let's take a general overview of what Django describes the secret key is used for. So taken from the Django documentation, there are 4 elements here. So first of all, the secret key is used for all sessions. So for example, using cookie-based sessions, the session data is stored utilizing the Django cryptographic tools. So the session data is signed, and signing data, that requires the secret key. So all messages, if you're using the cookie storage or fallback storage. So if you're not familiar with the Django messaging service, this allows us, and it's set by default, it's turned on by default when we utilize the start project. So the message framework allows us to display one-time notification messages to the user. For example, whenever they maybe submit a form, maybe there's an error, so we can send back a message to them that there is an error, for example. So that can be part of the message framework. Well, it just happens that the message framework allows us to temporarily store messages. And these messages can be stored utilizing cookies or sessions. And of course, cookies and sessions or session-based messaging, this is normally handled, the session data is normally handled by a Django cryptographic signing process. And again, that process requires the secret key. In addition, the secret key is also utilized for the password reset view tokens. And we're going to go through an example of this shortly. Something that everything here has in common potentially is the cryptographic signing process or the cryptographic signing tools in Django. So this is why it's kind of a focus here in this tutorial and why we're going to be talking about it next. So we're now going to explore the secret key, the concept of the secret key and cryptographically signed values through an example here. And this example is an example of a forgot password reset process. So let's imagine we have a website, a user has forgotten their password, they go ahead and select forgot password, that takes them to a page, and then they use that form, which allows them to enter their email address, and then they send that back to the Django backend. Django will have a look at that email or username, match it to a user in the database, and then generate a URL link, and then email that back to the user. Importantly here, the reset link, you can see it takes us to a reset page and includes what we can describe as a signed value. The next stage of the process, the user will access their email, click on the link. That link will take them to a new page in our website. the user can then use the form to update their password, and that password will be then sent to Django for it to then process and update the user's password. So maybe at this point you've got a number of different questions. For example, how do we identify which user password to update when the user types in their new password? How do we know that the reset request is a valid reset request? So for example, a user, any user, might just come along to our reset link here and add some values and then change a password. So yeah, how do we know that the user who's changing the password, who that user is? And then also, how do we validate whether the user has actually requested a password reset? So the key here, as you might imagine, is in this signed value. So this signed value can hold, for example, encrypted data that allows us to de-encrypt or unsign this data and extract data from this string. So for example, potentially, we can include data in this signed value here, and then we can go ahead and unsign this object, and then that will then return the data that's hidden inside. So if we were to, for example, let's imagine the user has gone through that first process of requesting a new password reset. So by doing that, the user's provided us their email address, and then we can match that to a user in the database. So now what we can do is we can extract that data from the database, user ID 1, and then we can couple it with the secret key to go through a signing process. And that process will then generate a signed value. And it's this value here that we pass over into the email and that the user uses to click on that link, and then that takes them to the password reset page. So this signed value that gets passed over or added into the link, we can capture that again when the user updates their password. So imagine the user's clicked on that link, it's got the signed value that we've generated, which has got this hidden data inside. And then the user goes to the page where they reset their password with the new password. They type in a new password, so we capture that at the back end of Django. But in addition to that, we can also capture this signed value. And then we can go ahead and unsign this value, and then that would then allow us to return the original value. So we now know what user we need to update. So what we have now is a way of adding the user ID and the new password into a query so that we can update the correct user's password. So maybe for obvious reasons, we wouldn't want to just pass the user in the URL because anyone could just come along, for example, go to the reset page or the URL and just type in user equals 1, for example, and pass it through. So by encrypting, by signing and creating a signed value, it allows us to hide the value of the user that we want to reset. But I've been utilizing this idea of a signed value, signed data. So that probably requires you to do a little bit more research. But to try and summarize that, a signed data is a kind of cryptographic mechanism. And that allows us to kind of verify the authenticity, and the integrity of the data that we've kind of generated. If you like, we could say it gives Django a reason to believe that the request was sent from a valid request or from a valid user. So hopefully at this point, we've kind of answered in basic terms, how do we identify which user password is updated? Well, when we create a signed value, we can kind of hide some data inside, and then we can send that to the user. The user can then utilize that link, and then we can unsign that value to return the value to then utilize it to create a query to update the user's password. So in addition to that, how do we know that the reset request is from a valid password request? Well, in general terms, if we were to create a signed value, it means that if anyone tried to tamper with this value, it means that when we go ahead and try and unsign this value, it would cause an error. We wouldn't be able to unsign it. So we are protecting the data inside, utilizing this signed value. Hopefully that'll make more sense if it doesn't at this moment when we go ahead and go over some code examples. So it probably isn't super clear at this point. The third question, why do we need to keep this secret key safe? Well, the reason why this might be is take, for example, the example I showed earlier, whereby we utilize the secret key, where we utilize the secret key, add some data, and go through a signing process. Well, if someone was to obtain our secret key, they could go through this process themselves to generate a signed value. Now, because our system is the same secret key as their system, what they could do is go ahead and access our reset page, and they could add their new signed value that they've created using the same secret key as what we're using, and they could then go ahead and change the user's password. Of course, if they then also knew the user's username, well, they then have the username and the password of that user. So if we take a look at the cryptographic signing documentation in Django, this is a 4.0, you can see that Django provides us the tools to actually utilize the cryptographic signing in our own application. So we're going to go through some simple examples here, very similar to the examples that are provided in the documentation to further understand this process and how potentially we could utilize these tools. So first up, to utilize these tools, we can see here that we need to utilize this signing module, we need to first instantiate the signer instance. For the following examples, we are going to be utilizing the Django shell. So I'll place a code in the top here as well, so you can just follow along and type it in. So let's go ahead and Python 3. Let's go ahead and manage.py and then open a Django shell. And so from here, we can go ahead and say, let's bring in the resource from Django.core.signing. Let's import, it says singing at the top here. That's wrong. I've typed in singing. Apologies. Signer. So let's import the signer with the capital. Okay. So now let's go ahead and instantiate. So signer equals signer. So we now have access to this signing tool, so we can go ahead and sign something. So rather than explaining, let's just go ahead and type some code in. So we're going to say x equals, and then we use the signer.sign. So let's sign something. So let's just sign some text, hello world. Okay, and there we go. So let's go ahead and just print that out. And you can see here what we have is the original text, and then we have this kind of signed value. So if you like, let's just think of this like a message, an old type of style message. I send you a letter, I go ahead and I sign that letter at the bottom, and that kind of validates that that message is from me. So you go ahead and read that message, you see my signature, you know it's my signature because you can validate it's my signature. And there we go. So it's kind of a similar situation here. This signed value here kind of commits and confirms that, for example, this message is from, in this case, this Django instance here. This signed value has been generated from the secret key. Now, without that secret key, we wouldn't be able to generate this signed value. And without that secret key, we couldn't go ahead and unsign this. So let's just, for example, let's just unsign this. So we're going to say that x equals signer dot, and let's just use, for example, y equals signer, and let's go ahead and unsign, and we're going to say unsign x. So that then reproduces hello world. So let's see what happens when we try to change this value in some way. So let's go up and find this again. So x equals signer.sign. So we're going to sign hello world again. So we've got this here. Let's go ahead now. Let me just bring that up slightly so you can see. Let's go ahead now and take what the value that's held currently in x, which is this here. And let's go ahead and just say x equals, and then, x plus equals, let's just add some values, equals something random. Okay, so we do that. Let's have a look at X now. And you can see I've just added this string at the end here to the sign value. Okay, so let's try now and go ahead and unsign this value. So y equals signer.unsign. And this time what will happen is that we get a bag's signature. So here we can say that by utilizing the secret key and making a signed value, if we were to manipulate that signed value in any other way, it would mean that it wouldn't be able to be unsigned utilizing our secret key in the Django project, and therefore it would cause an error. So this is a way in which we could ensure that any data that maybe we pass to the user that's been passed back, we can then go ahead and validate whether that was the original data or not. So while we're here, let's just move on slightly. Let's go ahead in the settings again. Let's just, for example, delete our secret key. And let's go ahead and we need to exit here. And let's go back into the shell. So now let's go ahead and just from Django, let's import the signer again. And let's just instantiate the signer. And notice now it says singer still. That's why. We'll do that again. So we instantiate, and notice now that we get an error. So we aren't able to instantiate the signer to start the signing process because the secret key setting must not be empty. So it's just really confirming the fact that this process does utilize the secret key. So let's move this forward slightly and go back to our example of the user who's forgotten their password. They use the password form, we validate their email, and then we go ahead and generate our signed value. So let's have a look, see how we can kind of encapsulate or encrypt data within inside the signed value. So I need to just go ahead and save that secret key again. Don't forget to save. If you aren't saving, there'll be a little dot here. So maybe go ahead and just utilize auto save, turn that on. So let's go back and exit this. One of two ways to exit there. So, and we go back into the shell. So this time we are going to, for example, think about how we can, for example, sign an object or put an object as part inside of this signing string, for example. I didn't explain that very well, but I think you get the idea. So what we need to do now then, let's say x equals, and this time we use signer.sign, but this time we use sign object. And now we go ahead and we pass in some values. So for example, key value, user ID, and then go ahead and add a value. Okay, so we'll go ahead and do that. And you can see that when we print out now X, you can see we have this signed value. And you can see this time, in comparison to previously, this object is now embedded in the actual signing process. So let's go ahead and unsign. So it's a very similar process. Again, instead of unsign, we're going to be utilizing unsigned object. So y equals signer dot sign underscore, sorry, unsign underscore object, and then we can print out y. And you can see this time it says bound method signer unsigned object of blah. So don't forget, you need to tell Django what it is you want to unsign. In this case, it's X. So go ahead and do that. And there we go. We now return the original data. So what we've done there is we went through the whole process of generating the user signed value and then going ahead. And we kind of simulated this process of unsigning the value and returning the data in preparation to add to the new password data the user's typed in to then generate our query to update the user's password. If you are thinking about utilizing the signer, we do have some validation tools here, and this is just an example of that. So here you can see, for example, we try the original or we try to return the unsigned data. If we do find that we find a bad signature, we can go ahead and print something and maybe exit the system, for example. So we can just quickly simulate that. So inside the shell again, I'm just going to bring and copy and paste all that in, and then we'll go ahead and I'll do exactly the same with this. So you will find a Git repository for this, so you can go ahead and do this. So we go ahead and do that, and you can see that we return successful because the original data wasn't tampered in anyway. So let's go ahead and, apologies, there's lots going on here. Let's go ahead and bring it down, change it slightly. So x plus equals now, let's just add a string to the end of it, of course. Yep. And now this time we should now expect to return print security warning, because we should return a bad signature because we tried to change it. So let's go back in. We're just going to copy all of this into the terminal. So this time we should return security warning. So a little bit of error control here. So going back to our example here, let's imagine we created this link for the user and then they didn't update their password. Well, this link will still be valid forever, almost, potentially. So maybe we could also add some sort of timestamp and work out a way so that this would only be valid for maybe a day. So if you have changed your password before, you probably know that this type of system already exists. When you do try and change your password, that link is only validated or valid, sorry, for maybe 5 hours or a day or 2 days. So we can also perform or add that into this signing process. So going ahead and just changing this, we can, from the core signing, also import the timestamp signer. Right, so we can now utilize this to create some sort of maybe maximum age. So let's try this again. So from original signer unsigned object, apologies, first of all we need to instantiate the timestamp signer this time. So we're not using signer anymore. We're going to be utilizing timestamp signer. So this time we can go ahead and now in the signed objects, let's pass in also the parameter max, max age. And we can do that in seconds, for example, so 5 seconds. So what I've done now is I've created a signature, assigned value, which is only validated or valid for 5 seconds. Now, obviously you'd want days rather than seconds potentially. And of course, there's tools in which you can do that. If you head back to the Django documentation here, there is a good example, a basic example of utilizing time delta. And it's well worth reading into time delta and how to utilize that if you're thinking about developing these type of systems or just utilizing time in general. So let's stick with our example, 5 seconds. Let's go ahead now and try this out. So I'm just going to copy this, go back into my terminal, and I need to open up the shell again. And this time I'm going to paste it all in, press enter. Now I'm going to wait 5 seconds. Should be okay now. And then press enter again. And you can now see I received a security warning. Well, that's probably because we're still manipulating. So let's just get rid of that. Let's go ahead and try this again. Apologies. So copy that. And we need to go back into our shell. So we're going to wait 5 seconds. And then hopefully we should still receive a bad signature. And there we go. So we're still receiving a security warning, i.e. there's a bad signature. And that's because we waited 5 seconds. So let's go ahead and just run this code one more time. We're going to paste that in again. And then this time I'm going to instantly run this, and you can see it's successful because I run the code in less than 5 seconds. So you can see that the timestamp is being utilized to validate the signed object for a certain amount of time. So just before we finish, I just wanted to establish some other points. So every time we build utilizing the default tools here to sign an object, we're always going to receive the same value. So take, for example, here, we're going to, for example, run this code and then print out X. So if, for example, I were to change this to 2, let's go ahead and run that. You can see that this value is different. However, if I would now change this value back and then go ahead and sign that, you can see that this value is exactly the same as the first value. So because we're using a default secret key which doesn't change and the value is the same, we're always going to return the same value. Now we can change this by using salts, etc. But just by default, that's the case. Now, let's just go through a simple process here. We're going to go ahead and run this code again, and we're going to produce a value. So let's print out that value. Right. So I'm just going to add this value here. So y equals, I'm going to say sign.unsign object, and then I'm just going to pass this in here. It's the same as saying x, for example, isn't it? I'm just going to put the actual value in rather than bringing it from the variable. So let's just make sure that is the case. Right. Okay, so we've got that in there. So I'm going to exit this here, and I'm going to go into settings, and I'm going to change my key. Okay, so I've changed the key now. So let's go back in to my shell, and then I'm just going to now run, bring in the tools, and then I'm just going to run this. And it says bad signature. So because I've changed the secret key, I can no longer run this or unsign this. So let's just change the secret key back. I think it was that. So I've changed it back now to the original where we initially made this sign value. And so we're going to need to just exit this again and then go into the shell again. And this time bring in the tools again. And now this time try to unsign. And because we changed the value back of the secret key to the original secret key, we can go ahead and unsign. So I think it's important for you to understand that again, because if someone were to take our or find out about our secret key, you can see, like I was talking about in the example, that person could actually then go ahead and create signed values, which could potentially be validated against our system, causing a security issue. So clearly we don't want anyone knowing our secret key. We need to make it safe. So let's answer the question, how to generate a new secret key. So in actual fact, Django provides us tools to generate secret keys. So back into the shell, from Django.core, and you can have a look at the GitHub repository for Django and actually go into the Django core folder and then look for management and then utils. And inside of there, you'll find a new function or function called get random secret key. Okay, so we can now utilize this to generate a secret key. So x equals get random secret key, and then we can print x, and then you can see it says function get, okay, because we've done that wrong. It's a function, so we need to call the function, apologies, and then that will return a value, and there we go. So we've now generated a random secret key. So at this point, I'm just going to lead you over to this little bit of reading, and another way for you to generate secure random numbers is by exploring Python's secrets module. So this is going to allow you to generate cryptographically strong random numbers, and that's going to be suitable for you to utilize in your secrets key. It does give you some interesting information here. Like a question you might have had is, well, how many bytes or how long should be your secret key? And it's suggesting here that 256 bits of randomness is typically sufficient for a secret. Now, if you were to look at the back end of Django, you will find it's actually utilizing secrets to generate your random key. So you can probably pretty much be safe by utilizing the tools that was demonstrated earlier, or else you can definitely go into here and generate your secret key if you wanted to, or you could obviously just build it yourself. Hopefully that's given you a few pointers. If you do want more information about utilizing Python secrets, I'll probably do a tutorial not too long from now anyway. And so it may already be on the YouTube channel if you're watching this a little bit later when they produce this. So by all means, go ahead and have a look at that if that exists. So let's move on now to taking measures to secure your secret key. So hopefully I've given you a sense of why you might want to keep your secret key secret. So let's talk about how to potentially keep your secret key secret. As we already know, when we create a new project, a secret key is generated. Now, if we are just developing locally, then it might not be through the development process, we need to do too much with this secret key because no one else is accessing it. If we are, for example, using source control like GitHub, we want to make sure that we're not uploading this to our GitHub repository because potentially that's going to be then accessible by maybe other developers, or potentially we make a mistake of having a public repository and then anyone can access our secret key. So a popular way of loading in your secret key, as well as other variables, for example, debug, maybe you've got some other parameters you want to load in that you want to keep secure. And this can be done through the environment variables. So essentially what's happening here is we can blank out the secret key here and load it in from an environment variable. And of course, we can safely then upload this to our source control because it doesn't have the secret key. And then we can keep that secret key to ourselves. And then when we deploy it onto our production server, we can load that secret key into the environment variables. And then that's not also then directly inside of our settings file, which is obviously a weakness. Everyone is going to be looking for the settings files if they wanted to access the secret key naturally. So let's go ahead now and, for example, let's import OS. So first thing, let's go ahead and import OS. So that gives us the tools to kind of access the directory. In actual fact, let's not do that. We're going to do it a different way. Let's a more assured way of doing this. So first of all, then let's just create a new file, a .env. So just .env. So this is an environment file. So in order for our Django to kind of load this in, we're going to need to tell it to load it in. So what we're going to need to do here potentially is pip install a package. So let's pip install python .env, and that's basically just going to load our env file or make it accessible here in the kind of development environment. So pip install that. Looks like I've already got that. And once that's now started, or once that's available, sorry, let's go ahead and say from .env, let's go ahead and import load.env. And like I said, what's happening here essentially is it's going to allow us to import and make this environment variables that we're going to set up available. So we can now say load load.env. So that now kind of loads this file up when we start the server. Right, so now we've got that in place, we can now go ahead and make a link from our secret key to the secret key that we're going to value that we're going to add into our environment variables here. So let's go ahead and do exactly that. So first of all, we need to define where we're going to find these new variables. So secret key equals, and then we're going to say os dot get env, and then that's going to, we're going to call this look inside the environment variables, and we're going to say look for let's just call this secret key. Okay, right, so let's go ahead and bring in os. Let's import os. Okay, right, so that's the secret key reference to the environment variable here. So let's now go ahead and go into our env file, and let's say we've called this secret key. So secret key equals, and then whatever our secret key is. There we go. So what's going to happen now, of course, is that we're going to make sure that the env file isn't part of, if we're using GitHub, for example, our source control, we're going to make sure that that isn't part of the code that gets pushed over to our GitHub repository. And of course, we can go ahead and build a new file, which is the gitignore file. So let's do that again. .gitignore, and then we go ahead and just add that into our gitignore file. Right, so .env. Okay, so having done that now, we're now kind of assured that that's not going to be pushed over to our GitHub repository. We can now go into our .env file. We've already done that. So I think we're ready to go. So let's go ahead and do Python 3, manage.py run server. And of course, if it doesn't work, then we're obviously going to receive the message we received at the start of this tutorial. So let's go ahead and refresh, and you can see that we have our instance of Django working, which is suggesting that everything is absolutely fine. Now, it probably is a good idea if you're working in a development environment to create a secret key for just development, and then potentially have another secret key that when you actually deploy the application, you use that secret key for deployment. That potentially is maybe a better way of working. Now, if you're wondering a little bit more about secret keys and environment variables, if, for example, when you want to develop or deploy this, you deploy this on a server, and then essentially what you're doing is you're loading those environment variables onto that server so that Django can then access it. And essentially what's happening here is that it prevents us from having to type in the secret key here. And potentially it's harder to access that environment variable for someone trying to hack the system. It's not impossible, but it makes it a lot harder for someone to access our secret key. Of course, if you're working in an environment where you have multiple developers, then having a secret key for development and having a separate secret key for deployment, obviously then also secures a secret key in your deployment environment. That was hard to get out. So there we go. I think we've come to the end of this tutorial. So I do apologize if you felt that information was a little bit lightweight. I tried to skim the fat there. There's lots of other aspects we could talk about. And if I have missed something that you were interested in, that you wanted to hear, then by all means, just leave that in the comments and we can definitely think about maybe exploring that in more depth. Likewise, some of the terminology that I utilize, I tried to make it a little bit maybe more friendly. I wasn't necessarily utilizing terminology that is maybe exactly correct, but like I said, again, I'm just trying to make the tutorial easier to understand. I realize that there are lots of people around the world listening to this potentially, and yeah, like I said, to say that again, I'm just trying to make it as friendly as possible. And if there is something that I've missed that you want to see or me to go into a little bit more detail, please let me know in the comments and we can definitely have a look at doing that. Again, thank you very much for listening. Hopefully I've covered all the main bases now and you have a better understanding of what the secret key is for and how to then potentially create signed values. And you could utilize that type of system inside of your application potentially for different aspects of your development. So thank you very much for listening and I hope to see you in the next tutorial.